Good afternoon. My name is Eddy Rodriguez Osoria, and today I'm going to present my reports about the history of the internet and the generations of computers. To the subject, technical English with Professor Miguel M. Gomez. Okay. The first part of this presentation is about the history of the internet. And I consider it to be one of the most important inventions in all humankind history because we use the internet every day for working, researching, studying, even shopping, just to stay connected with the people we love. So, have we ever wondered how did it all start? Well, and it is that the internet um, actually started around the 60s, not as a public tool, but as a US military project. Uh, Back then, computers were huge because they filled entire rooms and produced lots of heat. And also, to transfer data, people actually had to physical travel or mail magnetic tapes from one point to another, which was something that was very inefficient and slow, as we can all imagine. So the U.S. at the same time, there were fear of nuclear attacks due to the Cold War. So the United States wanted a communication system that could still work even if part of it was destroyed. That's how in 1958 the US government created ARPA, which stands for the Advanced Research Projects Agency, that later on in 1969 became ARPANET, the first computer network. Now, the first message that was sent through the internet, um, and it is that the first successful computer message was sent in 1969 between UCLA and Stanford University. The researcher at that time was Leonard Kleinrock, who tried to type the word login. However, the system crashed after typing the letters LO. So a fun fact is that the first computer message sent through the internet was law. The the internet wasn't just one invention that changed everything, right? It was developed through many inventions and time. So now in this part, I'm going to talk about some of the brilliant minds that helped create the internet. One of them was Paul Barron, who proposed the use of distributed a network instead of a central one. And it's because a distributed network can transfer data between every node of the system, and that's something more efficient and faster. And also, we have to talk about Lawrence Roberts and Leonard Kleinrock, who were the pioneers and helped develop the ARPANET project at the time. Bob Kahn and Vincent Cerf, they created the TCP/IP protocol, which is a protocol that it is still used today, and it helps computer networks to understand each other and can communicate efficiently. And also, we must talk about Paul Marketplace and John Postel. They created and distributed the DNS protocol, and the DNS protocol is basically a system that helps translate a website's name to their corresponding IP numbers, and because it's because computers can only understand numbers, and but is that's something very hard for humans to do. And of course, we have to talk about Tim Berners-Lee, who is considered the father of the World Wide Web. The growth of the internet is officially the birth of the internet is officially considered to be in 1983 when the TCP/IP protocol became the standard due to its implication of how computer networks could connect each other. And also, we must talk about because we must talk about Tim Berners-Lee that helped make the internet user friendly because at the start it wasn't, and it is because he invented HTML, HTTP protocols, and URLs to help display information on websites. And for in 1993, we Mark Anderson created the Mosaic browser, who was the first easy-to-use browser that combined text with images, and then later on became the Netscape navigator and helped the internet explode in popularity thanks to its easy way of uh, using it. Right now, for the second part, I'm going to talk about the generations of computers. And in this part, I'm going to explain how computers have evolved themselves through time, uh, thanks to new technology. Because there are six generations, each one marked by their technology, and um, and that has been sorry, and that made them faster, smaller, and smarter. The first generation of computers used vacuum tubes, and they were really huge because they filled entire rooms and produced lots of heat. They used machine language to give instruct to I mean to take instructions to execute instructions. Sorry, and used punch cards for input. Two computers that were from these generations were the ENIAC and the UNIVAC. And due to its size, they were and expensiveness too, because they were really expensive. They were only used for military and scientific purposes. Now, the second generation changed the game completely because they used transistors and that replaced vacuum tubes. And transistors were smaller, were faster, and also were cheaper to produce than vacuum tubes. In this generation, computers reduced its size thanks to the transistors, and they used assembly and started using early high-level programming languages to execute instructions, such as Fortran and COBOL. Two examples of computers of these generations were the IBM 1401 and the UNIVAC 11007. The third generation used integrated circuits or chips. They allowed many transistors to sit on one small silicon plate, which reduced its size and increased its speed. Also, in these generation, computers started using monitors, printers, and keyboards. And the computers of this generation allowed computed networks to exist, and that later on became the internet, right? Some examples of these computers were the IBM 360 and the PDP-11. The fourth generation of computers that are still the present of what we know and use today use they use microprocessors, right? That are basically the computer's brain on a single chip. They are much faster than the predecessors, the integrated circuit, because they allowed millions of transistors to be placed on a single chip. And also, this generation was from 1970 to the 1980, and sorry, and the companies like IBM and Apple released their first computers, personal computers, which means that they opened the age of personal of PCs, right? Of pieces, and for the for the fifth generation that is also happening today in the present, it is AI or artificial intelligence based, because these computers can learn, reason, and make decisions on their own, because they use parallel processing and ultra scale, ultra large scale integration chips with millions of transistors in it. And it is we see AI today with virtual assistants such as Alexa, Siri, also in self-driving cars like like Tesla's one, and of course in chatbots like ChatGPT that it has exploded in popularity in the recent years. Uh, Finally, we have the sixth generation, uh, which is still theoretical, but advances have been made, and they are focused on quantum computing and nanotechnology. And quantum computers use what are known as qubits that and qubits can represent both one and zero bits at the same time, and this can help computers to solve extremely complex problems. And although it is still experimental, companies like IBM and Google are already working on it, and it's in companies like Google have already made chips that are progressing the computing field very well. Um, that has been my presentation. Thank you from everything. Uh, we've seen how the internet started as a military U.S. Project and evolved to be a global network that connects billions of people, and how computers have evolved from huge machines and very rustic to one of to use even artificial intelligence and allowing them to make decisions on their own. So that has been everything from my part. Thank you very much for watching.